and welcome to Chapter 8. Today we are covering IP addressing. We will cover IP addressing number IPv4 and IPv6. As for most of you, IPv4 should be, you guys should be familiar with it. In fact, with IPv6 and IPv4, both of them, we do a lot of practice in class. So I have those worksheets that we've always been working with since the beginning of the term. And so you should be familiar with a lot of the stuff that we're going over, especially in the IP version 4. In the IPv6, we'll get to that. So pay attention when we get to the IPv6 network. You have to really pay attention for both, not necessarily just one, just at IPv4, but for both of them. Anyway, so let's get started because it's going to be a long chapter. So we have a lot of things to do. If you have not done any of the worksheet that we've been doing in class, this is going to be a little bit of a challenge for you. But pay attention because you can always come back to this chapter and it will give you a little bit of insight on how to, for example, convert binary to decimal to binary, the old classful IP addresses and things like that. All right. The binary notation, for example, you got to be able to convert decimal to binary, binary to decimal, for example. This is 102 because the 1 is in the 100, the 9 is in the 10th, the 2 is in the 1. So 1 times 100 is 100, and 9 times 10 is 90, and 2 times 1 is 2. So 100 plus 90 plus 2, that's how you get 190, 192 as a number. Same idea with the IP addresses, with the binary. The binaries are, you got to remember these numbers. If you remember, we did in the class from right to left, 1, 2, 4, 8, 16, 32, and 64. So wherever you see a 1, you take a 1 times 128 plus 1 plus 64, and that's how you get 192. If there's a 0, you just don't add the numbers on the top. That's how you can convert binary to decimal, by placing the byte right under these ones, and wherever you see a 1, just take the one on the top and add it to the one on the add wherever you see ones. For example, I see 2 ones right here. It's 128 plus 64, and that's it. I don't see any more ones, so that's the answer. All right, so for example, I see a 1 here. It's 128. I see 1 here, 132 plus 64. 128 plus 32 plus 16, that's what I meant to say. That's equal to 176. If you see all ones, if you add 128, 64, 32, 16, 8, 4, 2, 1, that comes out to 255. So you will never see an IPv4 address, a number in any of these octets larger than 255. And obviously, if they are all 0, then it's really a 0 decimal point. For example, let's say here is the IP address 192. So you put 1 because 128 plus 64 is 192, and then the rest zeros. 168 is 128 plus 32 plus 8, right? So that's why we put a 1, 1, 1, 0. And then 8 plus 2, which is 1010. That's how you convert it to the 192, 168, 10, 10, converted into binaries right up here. Right? And don't forget, these numbers are very important to remember. As we've been, worksheet number 1 that we did in class in week 1, this is what this is all about. All right. So if you know how to do it, you really don't have to worry about it. Now, going from decimal to binary. So for example, if they tell you what's 168, 168, there's a 1 and a 128 plus 32, 60. So you can't have 64, you put a 0. Can't have 16. So you need a 128, a 32, and an 8. And then the rest zeros. They do that by binary and whatever's left over. And when we get to class, I showed you how to do this too, right? If you're not familiar on how to convert binary to decimal or decimal to binary, please let me know. That's very important, right? So 192 is 128 plus 64. 168 is 128 plus 32 plus 8. 10 is 8 plus the 2. 8 plus 2, right? Now, network portion and the host portion of the IPv4. And the IP address has two portions. It's always the one portion of it is the network portion, is what really routers look for. And that's like the zip code. And the host portion is who you are in that network. So for example, uh, this number 10, this device is number 10 in network 192.168.10. Right? And if you have this number 192.168.10.10, I'm sorry, 192.168.10.10, how does the router know that the first three numbers are the network address? And the way it does is it takes a subnet mask address, like we discussed in class, and does what's called a logical ANDing. Whenever you AND a number with 255, you get the same number back. So this flows down. In other words, you are masking the host portion and revealing the network portion of the IP. So wherever you want to reveal, you put all ones. Whatever you want to mask, you made all zero. So by writing a subnet mask 255, 255, 255.0, you're saying I want to reveal the first three numbers or the first three octets of the IP address, and that's your network address. And by masking the host portion, which means making it zero, that means the address, the result will be your network address, which in turn it's going to be 192.168.10.0. So a zero in the host portion indicates the network portion of the IP. Again, here's another thing that we also discussed in class. Remember how to convert the slash number into a decimal format? These are the leftovers. For example, 1 with all zeros is 128. 2 ones is 192. 3 ones is 224. It's probably a good idea to remember these because they are very, very helpful and can make calculations for you without using a calculator much quicker. All right. So the examining the prefix length. The prefix length means the numbers, the bits that are in the network layer. So if you see /24, it's telling you, there are 24 bits in the network portion. If you see /18, that means the first 18 bits of the IP address are your network address. And the subnet mask address has 18 ones in it, right? Like we discussed in class. All right, so the first host, as we've discussed, you always add a 1. Remember that, and then you take the network address plus 2, subtract the 2, you get the 254. In this case, 256 minus 2. And if you subtract the 1 from 256, which is 2 to the 8, the last byte, you get 255. We'll get into details about these in class if you're not sure how this works. Okay, so how many hosts, for example, a /27 has? /20 for /27, how many bits are left over? 5, right? Because 27 plus 5 is 32. So if there are 5 leftovers, it's 2 to the 5. That's 32 minus 2. Subtract the 2, right? Why do we subtract the 2? Because the network portion, the all zeros, which is the network address, and all ones, the broadcast address, right? Like we discussed in class, you cannot assign these to hosts. So 2 to the 5 would be 30 hosts. What happened if you have a /28? How many bits are left over? 4, right? To get to 32. So 2 to the 4 is 16. Subtract the network and the broadcast address, subtract the 2, and you end up with 14 hosts. So a /28 gives you 14 hosts. All right. So all zeros in the network address indicates this is a network address. So 10.1.1.0 is a network address, and 10.1.1, all ones in the host portion indicates it's a broadcast. So that's why we got to subtract these two addresses. And anything in between 1 to 254 are your host addresses, valid host addresses. Right? So 1 to 254, as we discussed before. Okay, and we do the ending. Remember how you find out the network address? So if you have, like I just said earlier, 192.168.10.10 and you put a subnet mask, you want to filter down the first 3 bytes. So you put all ones up here when you do the ending. Anytime you end with 255, you get the same number back. Anytime you end with 0, you get 0. So here's your network address. Anybody ever asked you what's the network address for this IP? And you have a /24. /24 means you have 24 ones. You write 24 ones. And then there is 0, and you do the ending. 1 and 1 is 1. 1 and 1 is 1. 0 and 1 is 0. See? 0 and 1 is 0. 1 and 1 is 1. You just follow the ending gate. We'll discuss more of this in class. Again, I keep saying this because we're doing this extensively in class. In every uh, class that we have, we go over this because it's a lot of work. I realize that. And expecting you to know this in one lecture is unfair. All right, so how do you assign the static IP address? You go to your computer on the bottom right hand. You see that little computer. You click on it. And let me see if I can do that. So you go right here and open share, sharing in the network, change adapter setting, and I double click on the network. Well, this I have no connection, but let me see if I can do this. I go right here, check properties. All right, I don't have any rights to do this, but if you do, let me see if maybe I can go right here. No, I don't have any authority to change any IP addresses. How do you like that? This is the school's PC, and they're not allowing me to make any changes. All right, that's fine. But that's where I don't know if you guys are familiar. If you have this button right here, click, that means your PC will automatically contact the DHCP server and get these IP address configurations directly from the DHCP. If you click on this button, this says use the following IP address. That means you statically type these IP addresses in. That's where you put your IP address, your subnet mask, and your default gateway. All right, let's continue. How do you okay, this is the dynamic. Like I just said, if you click on that, that means your PC will automatically contact the DHCP server to get the IP address from. All right, a unicast address meaning one device sending a packet to another device. All right, simple as that. Broadcast address meaning one device sending a packet to all devices, but the router will not let that broadcast message leak outside this LAN. That's why we call this is a broadcast domain, which is a LAN. Okay? Multicast address is the process of sending a packet to multiple hosts. This is really using the IP address that starts with 224. All right, local link uses that, and we'll use that in OSPF. OSPF designated router use that to send packets to a group of users in a LAN, not everyone. We don't do really a lot of multicasting as I've discussed that earlier. Private IP addresses. Private IP addresses is block of IP addresses that are reserved for use inside a LAN. And you cannot use these IP addresses if you cannot go out. They're not routed on the internet. If you need to get on the internet, you send your packet, which will have that private IP address, the source IP address, stamped on it. Your router will be running a network address translation protocol, NAT, and NAT will translate your private IP to global IP address. You get on the internet, and when you come back, then your address is translated back. So any IP address that starts with 10, 172.16.2, 172.32, or 192.168, all these are private IP addresses, and they are not routable. Okay? Some other IP addresses that are special IP addresses you should know of. For example, we discussed the network and the broadcast addresses. Any address that has a 0 in the host and any address that has all binary ones in the host, That's a broadcast address, and all zeros is a network. You cannot be assigned to a host. A loopback address, any address that starts with 127 is a loopback address. This is for testing the local TCP/IP local stack. In other words, testing your computer to see if it can encapsulate and decapsulate packets. In other words, it can connect to a network using the ping command. Remember, we typed the ping 127.0.0.1, and that will allow you to test your computer if it can be connected to a network. You don't even have to be connected. It's really testing your computer if it can encapsulate a packet into a frame and then decapsulating that frame and pull the packet out. The link local address, other like a CompTIA, they call it the IPBA address, the automatic private IP addresses. That's the one that starts with 169.254. When your computer turns up and if it's set up to go for a DHCP server and it goes out and searches for a DHCP server and it doesn't find one, your computer will automatically assign an IP address that starts with 169.254. So if you typed ipconfig on a PC and it says that the IP address is 169.254, you know there's either something with the something wrong with the DHCP server, or your computer went out and looked for it and could not find one. Maybe configuration, not that the DHCP server is bad. All right. Testnet addresses, this is for teaching purposes, anything that starts with 192.0.2. And the experimental address is anything, this is the class D, the 240 addresses and higher. Now, legacy classful IP addresses, there were, in the old days, they were broken into 5 classes A, B, C, D, and E. If your IP address, the first byte of the IP address began with 1 to 127, then you were considered to be in class A. And then if you're class A, then your first byte is your network address and the rest is your host. If your IP address started out with 128 to 191, then the first 2 bytes are your network address and the last 2 bytes are your host. If your IP address is started with 192 to 223, then the first 3 numbers is your network address and the last one is your host. Here's your mask the slashes. /8, /16, and /24 is your default subnet mask for the classes A, B, and C. Classes D and E were not being used. Class D was specifically reserved for multicasting, and Class E for experimental. All right, we no longer really worry about classful addressing because now we really just use the classless, which means we'll use the slash. We don't have to look at the first byte to see what the number starts with and to find out what the network of the IP address is. We'll just do the ending process and figure out what the network address is later on. And that's what classless IP addressing is. All right, the assignment of the IP addresses. Who gives out the IP addresses? There are the regional internet registries. There are 5 of them around the world, and there they are as you can see them. All right, so the ARIN are the ones that are responsible for North America. That's the United States and Canada. So all the ISPs that are up here in North America, they go to the ARIN to get their set of blocks of IP addresses that they can sell. So they go from down here to, for example, from tier 3, there are tier 2s and tier 1s before they put you on the internet. So there are sets of layers of ISPs before you actually get on the internet. I mean, you can get into that. All right, anyway, that's it for IPv4. We will discuss IPv4 in more details next week, next chapter, chapter 9, when we get into subnetting. We're going to spend the whole day doing subnetting, and I'm going to show you an easier way of doing that. And before we do that, you should really know the worksheets, worksheet number 1, 2, 3 that I've gave you in class and practice them. I think also 4, if I'm not mistaken. Anyway, so I can show you an easy way to subnet. Chapter 9, it'll be long and will be cumbersome if you really have no clue and you haven't touched and practiced converting, knowing what a converting binary to decimal, decimal to binary, knowing, for example, the IP address format, the subnet mask address, the ending process, what's the slash and how to convert the slash into binary and figuring out and all of that stuff. You really need to know and practice all of that. And then subnetting will be an easy. It's just really steps that you have to follow. And we'll worry about that next week. All right. So practice the sheets and we'll be okay. Now let's get into IPv6. For most of you, this is maybe new to you. So pay close attention because this is a little bit completely different than IPv4. So there are several things that we need to look at. In 1998, IPv6 was ratified. So, and it's really taken over. The idea is, the envision is to take over IPv4. And in fact, in North America, I think the registry are no longer giving out IPv4 block addresses to ISPs. Now it's strictly IPv6. And the idea, but why did we go with IPv6? Because we were running out of IP4 addresses. By the way, they were working on IPv5, and and during that time, they figured we should also fix all the problems that IPv4 has. So they were thinking of other things that they wanted to do, and they started working on IPv6. And then what they did is they put IPv5 and 4 together. I mean, it's not that they skipped the number from 4 to 6. It's really 5 and 6, and now they just called it IP version 6. Just like I think Microsoft now is jumping and calling it Windows 10, and not skipping the 9. They were working on 9, and I guess, I don't know. I think they're coming out with Windows 10. Anyway, so because everybody needs an IP address, now we have got a huge number of IP addresses, 340, whatever, udecilin. So whatever that number is, it's really 2 to the 128. So if you can put that on a calculator or a computer, and you'll see how many actual IP addresses that are available for us. Okay. So it fixes all the limitations that IPv4 had, and we include an ICMPv6, which is really nice thing to have that IPv4 did not have. All right, now what happens when IPv6 now comes in and IPv4 is still there? So how do we do this? The best thing to do, which a lot of devices do, is they do what's called a dual stack, running both at the same time. All right, so if let's say I'm a device that's running both IPv4 and IPv6, if I receive an IPv4 packet, then I let the IPv4 software process it. If I receive an IPv6 packet, then I let the IPv6 software process it, and that's called dual stack. That's probably the best way to go. Tunneling and let's say I'm an IPv6 and the receiver that's going to receive my packet is also IPv6, but the network that we're going to send the data through is only an IPv4. In other words, there are only devices that recognize IPv4 packets as they traverse a network. So what am I going to do? I'm going to take my IPv6 packet and encapsulate it into an IPv4 to make it look like an IPv4 packet and sends it over that IPv4 only network. And so when it gets to the receiver will unwrap that IPv4 packet and pull the IPv6 packet from inside. By the way, wrapping a packet into another packet is what's called tunneling. Translation. Now, what you could do is you could translate an IPv6 into an IPv4 and an IPv4 into an IPv6. For example, if the receiver on the other end is an IPv4 and I want to send him a packet, and I'm IPv6. So what I do is I translate my IPv6 packet into an IPv4, send it out, and when he receives it, he will transfer IPv4 into an IPv6 and send it back. I don't like the translation, and most people don't use it. Um, what we do is this is really a translation technique. Dual stacking is much better and much more efficient as long as your device can handle the software. It's probably the best way to go. All right, we've discussed already how to convert decimal to binary, binary to decimal, and also hexadecimal number, because the IPv6 address is 128 bits, and you are not going to write 128 ones and zeros. It's a much easier way to write that um, IP address in a condensed form. And the best way to do it is to use a hexadecimal format. All right, so we do here, for example, let's say you want to convert the number CA, and C is 110, and then A is 101. A is 1010. All right, here's a typical IP address, 128 bits. Let's take a look at it. Each one of those digits is a 4-bit number. Every two numbers is called an octet, and every 4 digits is called a hextet. So this is one hextet, 16 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 hextets, 8 times 16, that's your 128 bits. Okay? And by the way, you can write them in capital or lowercase letters, the hexadecimal digits, the A, B, C, D, E, F. All right? So each hextet can go from 4 zeros to 4 FFs, right? Which is 16 zeros to 16 ones in binary. All right, so let's even though it's a 16 hextet and it's written in hexadecimal numbers, you still want to write that IP address in a more concise form, a shorter form. So the best, because there's going to be a lot of zeros, the best way to do it is omit a lot of zeros so you can write the number in a shorter method. And the way to do it, here's step number 1. What you do is omit the leading zero in an IP address. So if you have an IP address, this zero is insignificant, that can be taken out. These 3 zeros can be taken out. These 3 zeros, these zeros, these 3 zeros, and this 1 zero has to be taken out. Now you cannot take this, you cannot take these 2 zeros out because that's significant. The one to the right of a number you got to keep, but the one to the left of the number you get rid of. So you got to keep at least 1 zero, right? See, to the right of the number, you cannot get rid of it. So the number will condense to this. And when you shrink them, so it's a little bit more compressed, a little bit more concise. So rule number 1, get rid of the leading zeros, the least, okay? Because like you're saying, what's 07? Or get rid of, why do you have to say 07? Just say 7. Drop that 0. All right, now omitting omitting all 0 segments. So if you have a double colon right here, that means all zeros are in between these colons. You can put as many as you want, but the rule is you can only have ones in the address, one double colon, and you can have as many zeros as you want. In other words, you cannot have 2 double colons like this. Let's take a look at an example. For example, see, you have 2 zeros here and 2 zeros here. So what you could do, you can eliminate these 2 zeros and just put 2 empty colon with nothing in between. But these 2 zeros have to be carried. And the reason why, because now you know there are 2 zeros in here. And that is because we have 1, 2, 3, 4, 5, 6 hextet. That means, and I know there has to be 8. That means that empty colon has to be 2 zeros, right? Now you could do it this way or that way, but you cannot have empty colons here and empty colons here. Because if you do, then you don't know. Then you have 1, 2, 3, 4. And if this was also empty colon, what are you going to do? Is it 4 zeros here or here? Is it 3 here or 1? You won't know how to do that. That's why the rule is to have only one empty colon. And with the most zeros, preferable with the most zeros. So for example, here's the 3 zeros. You put empty colon and you write everything else with the leading zeros, of course, gone. So this is so when you see double colon with nothing in there, you know there are zeros. All right, so IPv6 length. When you have a slash number, the slash is going to indicate the network address, just like an IPv4, right? So the prefix, the first 64 bits of the IP address is really indicating what registry you are from, who is the ISP that got the numbers from that registry, and also in there will be the site, for example, the company that got the IP address from that ISP. Really, those first three things, the registry, the ISP, and the site, is the /48. And there's another /16 is for subnetting. So there are reserved 16 bits for subnet, so that company can create 2 to the 16 is what? Like 16,000? Oh, 2 to the 16 is 65,536. That's how many subnets they can create. And you don't have to do subnetting. So that block of 16 bits from 48 to 64 are reserved for subnet. The last 64 bits is your ID, your host. So when you see /64, that's your network address, really. There are three different types of IP addresses, IPv6 addresses. There's the Unicast, the Multicast, and Anycast. And as you can see, there's no broadcasting with IPv6. All right, so that's it's really a multicast. That's what it is. It's not that they just get rid of it. All right, so well, actually, there's no, you don't put all ones and an IP address to broadcast. None of that. It's just a regular multicast address, which we'll discuss later on. A unicast IPv6 is just the same idea as a unicast for IPv4. You're trying to send a packet from one device to another device directly, right? So this guy, 201 ACAD subnet 1. So this 201, so this 8, this 16, 16, and another 16, these first 48-bit numbers as your network address, he's in subnet 1, right? And he is sending a packet to this guy. Okay. Actually, there should be a 10 here. He's the source, and this guy is the destination, right? .8. This is .1. See, they all have the same subnet 1, 1, 1. That's on the 1, 1, right? He's .1, colon 1. His host address is 10. He's 20. He's 8. And the printer is 9, right? All right, so let's get into the unicast addresses. There's the global unicast address, the link local, loopback, the unspecified address, unique local, and the embedded IPv4. Let's take each one at a time. Global unicast. This is similar to the public IP address that is assigned to you. This is the IP address that you are going to use to get on the internet. So as a device, you will have a global unicast address, and anytime you want to access the internet, you will use that IP address to go on the internet with. Okay? That's it. You can either statically type it in, or you can dynamically get it from your router or your DHCP server. Link local address, the local address that are designed only to communicate within a group, like, for example, into a classroom. If the classroom has a link local address on that switch, on that interface of the router, and you can only communicate with those. You can print, you can go to your file server, communicate with other devices in the LAN, but you cannot leave that LAN with that IP address. So you're going to have two IP addresses. One IP address to communicate with the people inside your LAN, that's called the link local, and another IP address that you are going to use to go out on the internet with. That's called the global unicast address. And you may have another third IP address called the unique local. Unique local is like private IP addresses that you can use inside the building from one LAN to another. They are routable between LANs inside the building, but you still cannot get on the internet with them, the unique local. Okay, we'll discuss that in a second. The loopback address is calling 1. This is similar to the 127.0.0.1 IP addresses. So if you go to your computer and you ping calling 1, you're going to get a reply, right? This is very similar. It's exactly the same as the IPv4 127.0.0.1. This is to test the local host for connectivity. The unspecified address, if you get an address with all zeros, that means the interface did not find an IP address. This is similar to uh, the IPv address that I discussed earlier, right? That means we don't have an IP address, so I'm giving you all zeros. I was not assigned or given an IP address from a DHCP server. Okay, there's the unique local. The unique local that starts with FC all the way to FDFF is the one that you can use inside your building. All right? Similar to the private IP addresses, but you still cannot get on the internet with it. So you could be assigned 3 IP addresses in IPv6. A global IP address to allow you to get on the internet with, a link local to allow you to communicate within your LAN, and a unique local to allow you to communicate between LANs in a building, for example. The IPv embedded is the translation between IPv4 and IPv6. We're not covering this in this course, so maybe we'll do that some other time, but not at this time, because it's a little bit more challenging. All right, the link local. The link local always starts with FE80. Every IP address, every device that has IPv4 enabled will have um, the link local. Will have a link local. It's required. It immediately comes up. So when you type ipconfig, you'll say your PC has an address FE80 with a number at the end. It automatically comes up there, so you don't even have to bother. This is to automatically allow you to communicate with everyone in your LAN. In fact, I can get a lot of my information from my router too. Okay, so here's a link local. I immediately have FE80 subnet quad A's. This is quad B. Well, actually, that's his IP address. That's his host. Quad A, quad B, quad C, and so on. So they talk with each other. And by the way, you send data to the default gateway using your link local and using the link local of your default gateway. And then when you get out, you use your global IP address. Okay? So the global IP address are the ones that are given to you by the registry, internet registry, the regional internet registry. So those are the ones that you actually pay for. And usually they start with 001. So our IP address will always start with 2000. That's it. Or or for example, a 2 or a 3. But typically it's always a 2 because we didn't even get to 3 yet. Okay, so whenever you see an address that starts with 2, you know that's a global IP address and you use that to get on the internet. Okay, so let me repeat again. So here, when you see this number 2, it means it's the global IP address. Let's break this down. This is the global routing prefix, the first 48 bits, which is these numbers, the 2001, 0dB, ACAD, By the way, Cisco, in our Cisco Academy, we use this practice number always are. We'll use the first 48-bit numbers are always going to be 2001, 0DB8, ACAT. And these three hex stats indicate the registry, the ISP, and the customer or site. Those are the first 48-bit numbers. The next 16 bits is going to be your subnet in that site. So that makes up the first 64 bits, and that is your network address, right? And the last 64 bits are your host address. So the last 64 the last 64 bits is your network address always. So for example, here is your first 4 hex stats, and here's your last 4 hex stats. And this is, for example, he is 02, right? That's his interface or host address, host portion of the IP. All right, so how do you assign IP addresses to an interface? Just like we've been doing for you, type INT, interface G00, the gigabit Ethernet, and you say IPv6. So instead of saying IP address, you say IPv6, and then you type the first 64 bits, subnet 1, the first 48 bits, right? Then the subnet that he's in, and you put colon 1. What does this colon means? That means he is 01. Actually, the host address is here. His 64 bits. Well, colon means all zeros, right? 1. He's in subnet 2 because he's on this side, right? He's in another LAN. He's in subnet 2 and he got dot 1. And this guy's in subnet 3 and he is dot 1. But they all have the same first 48 bits, right? And they got them from the ISP. This is the subnet in that site. Okay. On the device itself, you can go where we tried to go in and configure the IPv4, and this is where you actually put the IPv6 address. You put the IPv6 address, that's the host portion, and you say /64 means the first 64 bits are going to be your network address, and then the rest is going to be your host. Here's your default gateway. Pretty much the same way. You can put a slash number. You don't have to put 255, 255. Remember we used to do that with IPv4? Here we just put the /64, saying that the first 64 bits is your network address. And that's it. Now, dynamic configuration of the global unicast address using stateless address auto configuration, or from now on we'll call it SLAC. What that means is your computer, your device, will automatically go to the default gateway and ask the default gateway to please give me the prefix, the first 64 bits, and give me your name, the default gateway address. And then when the default gateway gives you the first 64 bits and it gives you his IP address, then you create your own IP address, append that to the 64 bits that you gave it, that the default gateway gave you. So you make up your own IP address, and you already got the default gateway address from the default gateway, and you automatically configure yourself. So without having a DHCP server, so that's the trick. The idea is because ICMPv6 allows you to do that. So your computer using an ICMP version 6 router advertisement, by default, it goes out and sends it here, say, hey, I need IP addressing information. You immediately communicate with your default gateway using your linked local address, and then your default gateway will automatically configure you. You don't even have to have a DHCP server, and you are automatically configured. You get the global IP address, and you start communicating. There's no need to set up a DHCP server if you don't want to, but you could use a DHCP server as well. You can also configure these statically if you want. I mean, you don't have to ask for that slack, but that's the default. So there are three choices that you can have. You can have Slack only, which means you get all the information to configure yourself from your default gateway, or you can do Slack and DHCP version 6. You can get some of the information from your default gateway and the others from the DHCP server, or you can say, okay, I don't want anything from the default gateway because I have a DHCP server set up. Let me get all that information from there. So you can have um, all these three different options that you can use on the router to enable IPv6 to allow to automatically assign all of these IP addresses. You will have to enable IPv6 unicast routing. So if you don't type IPv6 unicast routing, you cannot do Slack. The only way you can do Slack is by typing IPv6 unicast routing on your router. Make sure you type EN, enable config T, and once you type that, then you type IPv6 unicast routing, and then if you go to your computer, and your computer will automatically talk to your default router now and will be able to get that information from your router. Without having this IP address typed on the router, your computer will be unable to do Slack to retrieve that information from the default gateway. We'll practice some of that in lab. All right, so here's example number 1. Your computer says, I want information from you. Please give me everything. So I need addressing. So he says, all right, I'm giving you the prefix, the first 64 bits, and I'm giving you my default gateway information. And he gives him everything. All he has to do is make a host portion of his IP. He can either randomly do that, or as we will discuss later on, he'll use his MAC address to create the host portion, and we're done. We don't need a DHCP server if you're going Slack only. The second type is you want to go half and half. You may want to use the dynamic host configuration protocol. So you can say, hey, I need some information. And then the router says, listen, I can give you the prefix length, but if you want anything else, go to your DHCP server, get the rest. Like if you want a DNS information, if you want to know who's the default gateway for you, go to your DNS server. It can help you do that. The other option is to go with, DHCP only. All right. Now, once you let's say you did Slack, Slack only, and you got your prefix and you got your default gateway. Now you want to make a host address. In the old days, prior to Vista, your computer went to the MAC address, grabbed the 48-bit number, and inside that 40-bit number, placed FFE in there. And then that expanded the 48-bit number, the MAC address, into a 64-bit, and that you used that as the host portion. It's called the EUI 64 interface ID. Here's how it works. So let's say you got all that information using Slack from the default gateway, and now you just want to make the host portion of the IP. So what you do is you go to your MAC address, grab your 48-bit number, which is right here, then separate the OUI and the device identifier, that's the serial number of the vendor. Separate 24 bits here and here, and then you insert FE right in here, and take the 7th bit and convert that FC into FE. And that would be your host portion of the IP. Okay? That's it. Simple as that. FC becomes FE and you're good to go. And there will be your host address. Okay, and it'll be unique. That's a little bit cumbersome, by the way. By default, for example, here is your MAC address over the gigabit 00. And here it would be your IPv6 address using your MAC address with FFE in the middle, right? You see that FC also convert to FE. Now, most people don't bother doing that with Windows Vista. And after that, we started generating the interface ID randomly. So what I do is as soon as I get all that information from the default gateway, I'll just pick up a number and throw it in the randomly create a number and throw it in the host portion. And then I go out and tell everybody in my LAN, hey, does anybody have this IP this host portion? And if nobody says, nobody agrees, then we're good to go. Nobody says, yeah, I have that. I made up that address too randomly. What is the probability that, when you randomly make up a number, because you have 64 bits and 2 to the 64 is how many different numbers that you can pick up randomly. So it's almost impossible to get the same address as someone else in your LAN, in your site that has that IP address. So randomly seems to work a little bit better and it's easier and quicker. Okay. So dynamic local addresses. After the global unicast address is assigned, an IPv6 will automatically generate its local link. Okay. And it will use the same subnet that you used. So as soon as you give it a global IP address, you automatically get a local link, the one that FE 80, right? And it will use the same subnet and the same, well, actually, some of them will not use the same host, as we will see in the lab. It will use a different, some of them will use the EUI64, others will use the randomly generated one. But you want to make sure that you have the same host for the global address that you were given, and the same host portion for the link local. It's best to do that. Okay. So the randomly generated is the one with the FE0. You want to be to randomly generate that. And how do you assign a static link statically instead of having it being generated automatically? Just type FE80 : 1 link local. Once you type that, that means you want that address to be the link local for that specific interface. That's it. By the way, as you can see, 0 gigabit 0001 and the serial 000, they all have the same link local address, FE80 : 1. Why is that? Why can they have the same address? Because the linked local addresses can only be used inside that LAN. They do not communicate with these addresses outside. So you can have the same link local in two different LANs, right? You could do that because they will never use them to communicate outside their LANs. So that's allowed. But you can't have the same link local address with someone else in your LAN, right? Your host has to be different. Okay. How do you verify? You just type IP, verify IPv6 configuration. You just type show IPv6 interface brief, and you can actually see here is the link local using the EUI64 as the host, and he's the global, the randomly generated one as the host, right? So you got two addresses right here for that gigabit 00. Show IPv6 route that displays the routing table for IPv6. So if you want to reach this network, you can go to this gigabit 00. If you want to reach this network, the /28, you can, and so on. We'll discuss this more in details next semester when we talk about routing. But show IPv6 route displays the routing table for IPv6 networks. Now, let's take a look at the multicast addresses. Multicast addresses is any address that begins with FF. So, in addition to your link local, remember that, global address, unique local, you can also be assigned a multicast address, the one that you can use to something to do similar to get broadcast addresses, right? So there could be assigned or solicit. So any address that starts with FF02, that is something similar to your broadcast address. So everybody will have FF02 on them, especially the routers. So when they receive a broadcast message, and that is going to be for their LAN only. So when you send a network to FF02 colon 1, then then the router will send that to everyone in the LAN, that broadcast in the LAN. All right. Now, a router becomes a member. Now, there is FF02 colon 2. That means multicast addresses for the router. So IPv6 router can only join the broadcast, like the default gateway, if you enable IPv6 unicast routing. Again, we'll see that with an example that we do. So a router can have O colon 1 and O22, two global two multicast addresses. Okay, so here is FF02, and here is a This is the all nodes, right? So an IP address can be sent to all the hosts. This is similar to broadcasting. So that's why we say there is really no broadcasting. Now there's also a solicit IP address, multicast address. I can go and that starts with FF02, and then the last two is FF00, and then the last 20 bits are taken from your global IP address and append that there, and that will be your multicast address. So if anybody sends that IP address to you, you'll get that IP address automatically, right? The least significant 24 bits are placed all down here from your global IP address. I put it right here in a attach it to these 104 bits, and that will be your solicited multicast address. All right, that's it for IPv6. So next thing we're going to do is, when we get to class, is do some exercises so you can actually see this in action, right? How to configure the IPv6, and the more we do this, and the better you'll have, better hands-on you'll have on it. All right, connectivity verifications, like using the ping command, for example. Now, ICMP version 4 allowed us to do pinging, this is when you have time right out. Let us know if my packet got lost on the way. Now with IPv6, ICMP version 6, the Internet Control Messaging Protocol version 6, they do all of that, plus they allow us to communicate with the router using the RSA, the RAs, the router advertisement, enable us to do the Slack, the ICMP v6, so a much more enhanced. IP protocol is not a reliable protocol, like we've discussed last week, the week, chapter 6, I think. We did the network layer. It's connectionless, so you needed the ICMP protocol. Remember we mentioned that? That's a separate software, was designed specifically because IP was not a reliable. In other words, if I send a packet and it got lost, I want to know that the packet never reached the destination, right? So ICMP is there to help us out. Router solicitation and router advertiser messages are the ones that allow us to do the Slack. So they are always sending information and trying to solicit information from the PC. They are the ones that get allow you to do the multicast addresses, to do the Slack, for example, right? And this is the router information when you do the Slack. Now also, for example, if you randomly generate a host address, it'll use the DAD, the duplicate address detection. So in other words, let's say I generated a host number 10, then I send out the DAD, say, hey, does anybody have host address 10 in my LAN? because I want to make sure no one else is using it. So if nobody responds, then I'm good. I'll use number 10 as my host address, right? So that's much easier than, well, I don't know if it's easier or not, but it's easier to work with than just going to the MAC address and creating the host portion of the IP using the MAC address. All right. So you can use the neighbor and discovery protocol. In other words, they send information to your neighbor to gather some information about who your PC is. Here, this one is, doing the DAT. All right, saying, hey, does anybody have that IP, the same host portion that I did? All right. How do you test the local stack? Doing ping 127.0.0, right? Like we've discussed before. You want to test to make sure that this is IPv4 testing. If you want to do IPv6 local stack testing, you do ping what? Remember? Colon 1, right? That's similar to the 127.0.0.1. If you want to test your default gateway, you ping your default gateway. That's called an echo request. And an echo reply is when the device replies back to you, right? You can ping someone else in a different LAN, right, to see if they are connected. By the way, when you're pinging someone and they do reply, that means the bottom 3 layers are good. You may ping that person and you can reach them, but let's say you want to send them an email and you can't. That's because the router may be blocking port number 25 and not allowing you to send email. That has nothing to do with pinging, right? He may exist, but there's some securities that are not allowing you to reach the email. So remember, the ping command only tests the bottom 3 layers. It does not actually test applications. All right. Trace route, actually, if you ping someone and that ping failed on the way to the destination, then you may use the command trace route and you can figure out exactly where your packet failed, which hop. We will do this in class. We will do some testing in class. And the best way to actually is to see this live. All right. And that's it. So I thought it was a little bit longer, but I guess we didn't do too bad. I'm not talking about. So again, I keep saying next week. In chapter 9, we're going to do subnetting. So please, if you are not sure how to convert binary to decimal, decimal to binary, review those worksheets that I have for you to do in class. Also review the subnetting, not the subnetting. Review the subnet mask address, the ending process, because we'll be going over that. I think when you see the IP subnetting for IPv4, it'll be a little bit easier than going through the whole chapter. But we'll see about that. We'll talk about that next week. All right. For now, just read up your book, and if you have any questions, please ask. Now, the questions, I did not ask you anything on the questions. Here's the question number 1 that you have to answer. What are the different type of unicast addresses for IPv6? They are link local, global, unique local, and the multicast address. All 4 can be assigned to an IP address, to a device. Okay? And I want you to list the 4 classes of the IPv4, the 5 classes of the IPv4. Remember that chart? You can go back and look at it. All right, so that would be question number 2. All right, so that'll be easy way to get to them. All right, so until next chapter, study hard, read the chapter, and if you have any questions, please don't be afraid to ask. All right, and I'll see you in chapter 9. So as for now, I'm going to log out, and good night.